Hello and welcome to our YouTube channel. Today we are going to be solving some problems in pre-calculus. We'll be under the topic proving trigonometric identities, and we have a lot of problems to solve. So let's quickly get into this video as we solve example number 1. So we are told to prove that sin theta minus cos theta plus 1 all divided by sin theta plus cos theta minus 1 is actually 1 over secant theta minus tangent of theta. So to do this, I'm going to begin with the left hand side, simplify the left hand side till I have something on the right hand side, which is the expression. So the first thing I'm going to do is to rewrite the expression as sin theta plus 1 minus all divided by sin theta minus 1 plus cos theta. That's the first thing I'm going to do. Now, once I have done this, I want to know if it is equal to this side, but I'm not going to keep writing this side. What I'm going to do is to rationalize the numerator of this expression. So I'm going to consider this to be the first term and this to be the last term. So if you have a minus b, the rationalization factor, which is the conjugate of the expression, will be, so I'm going to rewrite sin theta plus 1 minus cos theta all divided by sin theta minus 1 plus, multiply this by sin theta plus 1, and the conjugate of this is plus cos theta all divided by the same expression sin theta minus 1 plus cos theta. Now once I'm done with that, the next thing I'm going to do is to multiply both the numerator and the denominator. So go ahead and multiply the numerator. This is a minus b times a plus b. And if you multiply these two expressions, you have difference of 2 squares. So I'm going to have this times this is sin theta plus 1 all square, and this times this is minus cos square theta. Great. Now multiply sin theta minus 1 times sin theta plus 1. If we do that, we have sin theta minus 1 times sin theta plus 1. Great. Now, once we do that, the next thing to do is to multiply sin theta minus 1 times cos theta. So we have cos theta times sin theta minus 1. And then from there, the next thing again is to multiply cos theta by sin theta plus 1. So we multiply cos theta by sin theta plus 1. The next thing to do is to multiply cos theta by cos theta. So cos theta times cos theta is cos square theta. So from here we can go on to simplify. So we want to expand this entire parenthesis. We use multiplication of binomials. So it's sin theta plus 1 times sin theta plus 1. So we square the first term, that's sin square theta, plus multiply the first and the second term, that's just sin theta, and times the result by 2, that's 2 sin theta. And then you square the last term, that's 1, minus cos square theta all divided by. Now to expand this, multiply sin theta by sin theta, and that's sin square theta. Sin theta by 1 is sin theta, minus 1 times sin theta is minus sin theta. So the middle terms are going to cancel out, and then multiply negative 1 times 1, that's negative 1. Great. Plus cos theta times sin theta is cos theta sin theta. And then cos theta times negative 1 is minus cos theta. Cos theta times sin theta is cos theta sin theta. And then cos theta times positive 1 is positive cos theta. And then we write plus cos square theta. So we are going to group sin square theta and minus cos square theta. So we say sin square theta minus cos square theta plus 2 sin theta plus 1 all divided by. Here we have minus cos theta, we cancel out positive cos theta, and then we have sin square theta plus cos square theta, that's 1. So I'm just going to write 1, and then we have a minus 1 plus cos theta sin theta plus cos theta sin theta is 2 cos theta sin theta. That's all we have. And we can go right here to simplify this side. So sin square theta minus cos square theta is minus cos 2 theta. This is an identity. Sin square theta minus cos square theta is minus cos 2 theta plus 2 sin theta plus 1, all divided by, now this one and this one are going to cancel out. We just have 2 sin theta cos theta. So from there we can write minus cos theta plus 1 as 1 minus cos 2 theta plus 2 sin theta, all divided by 2 sin theta cos theta. 2 sin theta cos theta. Now 1 minus cos 2 theta is an identity, and that's 2 sin square theta. So I'm going to write this as 2 sin square theta plus 2 sin theta, all divided by, here it's going to be 2 sin theta cos theta. Once we have this, we can factor out 2 sin theta from the numerator. So from the numerator we have 2 sin theta, parentheses open. Here is going to be sin theta plus, and this entire thing is going to be 1. This time this is going to give us this, all divided by 2 sin theta cos theta. Now 2 sin theta will cancel out 2 sin theta here, and we'll just be left with 1 plus sin theta, all divided by cos of theta. And if we want to get something like the expression that we are told to prove, we have to rationalize the numerator here. The numerator, we multiply this side by 1 minus sin theta, all divided by 1 minus sin theta. So we multiply 1 times 1, that is 1. Sin theta times negative sin theta, that's minus sin square theta, all divided by, multiply this, we have cos theta times 1 minus sin theta. So what is 1 minus sin square theta? That's obviously cos square theta, all divided by cos theta times 1 minus sin theta. We can reduce cos theta and cos square theta. This goes here, it goes there, cos theta times. So it's cos theta, all divided by 1 minus sin theta. Now lastly, we divide each term by cos theta. So we divide each term by cos theta, we have cos theta over cos theta, all divided by 1 over cos theta minus sin theta over cos theta. If we do that, we have cos theta divided by cos theta, and that is 1, all divided by 1 over cos theta, that's secant theta, minus sin theta over cos theta, that is tangent theta. Remember, we're told to prove that that expression is equals to 1 over secant theta minus tangent theta. And we just did all of the simplification, and we came to 1 over secant theta minus tangent of theta. So this is the result.